Yo, yo, yo. Joe from CodingBlocks here, doing more stuff on the internets, trying to code these blues away. And today, very special day, I was going to get started on the 30-day LeetCoding challenge on LeetCode.com. And the first problem should have unlocked at midnight PST, and it's now 8 a.m. Eastern time, so that should be plenty of time. So let's do that. Yeah, move some things around here, get comfortable. Got my coffee made, ready to go. Been up for a while, and so I have no excuses. All right. So here's the first problem. It's set up a little differently than I expected. I don't know why it looks different. So I don't see a problem with it. Okay, looks like I can do all the same stuff. I don't know why it looks different. I guess I've never done a kind of set of problems like this. Well, it's all good. All right, so first problem, single number. Given a non-empty array of integers, every element appears twice except for one. Find that single one. Okay, your algorithm should have a linear runtime. Okay, and can you implement it without using extra memory? Okay, so for example, 2, 2, and 1, then we can output 1. All right, here we can see 4. Naive way to do it, the simplest way, I'll go ahead and write this out, is to loop through the array and build up basically a hash, and have it give it a count or something. That's yucky. So the key would be the main number, and you could have a count or something. And then later you can go back through and look for anything that doesn't have a count of 2. But that's just seems kind of dumb. Later find 1 with 1. And it would be linear runtime, but it's definitely using extra memory. We're going to have this hash table here, and then I've got to loop through the hash again, which is going to be roughly half the size of my input. And it's not going to affect my big O. So technically it's not going to affect my runtime, but it's just kind of, I don't know, just unnecessary. So I'm going to try and think about a better solution that is not too terrible to type here. And I think it won't be too bad. Like another way to do this, especially when we kind of got the hint that there's a way to do that without memory. It reminds me of a multiplication problem once. There's a puzzler I'd heard about from Michael Outlaw, how to swap two variables without allocating a temp variable, and how to swap two integers. And the secret was to basically add them together and then subtract one of them. And then that's how you can do that. And so I'm kind of thinking here about adding these numbers up. I do have to worry about large integers overflowing. Does it say anything about my number size? So I don't know. I think I might just go for that. It's not going to work for large numbers, but I'm doing it in JavaScript anyway, which is pretty good about big numbers. So I have a feeling that this is going to work out just fine. And this is probably the trick that they are angling and kind of hinting at. So what we're going to do then is loop through the array. And then, wait, how does this help me? Add up the numbers. Say anything about each number only being there once? Wait, yeah, I don't, unless I was kind of assuming that I would know the set of numbers here, but I don't. So I don't know that I'm going to be able to add, although that does seems a little too convenient to not consider. It seems like that should be part of the trick, so I'm going to keep thinking about it from that angle. So if I add this up, 2, 2, 1, I get 5. How do I know this was the number? Same here. 4, 5, 6, 7, 8, 9, 10. How do I know that you were the one? Every element appears twice except for one. Can you implement it without extra memory? All right, I'll tell you what, let's just go ahead and solve this problem kind of the naive way. And we'll come back to this because I have to get to work for the day. And maybe I'll come up with some sort of trick here while I'm kind of thinking about that. And it's a good idea to just kind of solve the thing first and make sure you truly understand it. So I've got an array of numbers. Make sure my output is the element. Yep. All right. So we'll set up our result here. Scene numbers. Yeah, I'm thinking I'm going to build up this entire structure anyway, right? So maybe I'll just be totally lazy. Just create a new set from these nums. That will give me a distinct set. And then basically, it's not efficient, but I can loop through each number. Oh, yeah, there we go. Okay, so I'm going to do a little addition here, but it definitely involves the memory, but I'm kind of coming to terms with that, I guess we can say. So we could do something like scene numbers dot reduce, and I always forget the order of the arguments here. I think it's sum, and then the current value. And we're going to do is basically return sum plus the value. So that'll sum up my numbers in the set. And I'm going to do the same thing for my nums. It's my input. So it's going to be this minus that will be the number that's duplicated. So I did my addition trick, but it's not actually removing any memory. So this is actually doing even more redundant work than my brute force solution I was originally thinking about. That stinks, but you know, such is life. Did I not click this? I've been having problems with my mouse lately. Ah, answers were down here. Hey, look at that. Oh my gosh. So, can I not do that with sets? This is why I'm using JavaScript right here. If I have a set of numbers, I cannot reduce. I could probably convert back to an array somehow. There we go, entries. Oh my gosh, I might have to Google how to iterate through a set. So it does have a for each, but what I really want is to reduce because I don't like typing. I'd rather just Google and type more. New set. Ah, look at that. Just put it in brackets. Okay. So we're gonna, I forget what that's called. Does anyone remember? I don't know how to Google for that really. This makes me uncomfortable, so I'm gonna do that. All right, now let's see. I keep wanting to say denature, but that's not true. All right. Oh my gosh. How is this the case? So when I added up the set, it was 5. No, sorry. It was 3. Oh, this is total. I'm wrong. My little slick answer here is not correct. That should have ran it by hand once. So I added up 5, then I subtracted 3. So that's funny. The way, so basically the problem I solved was how to find the duplicate number in a set, not how to find the single number. Okay, we're going old-fashioned here. It's gonna solve the problem because it's almost time to get to work. So, oh my gosh. Hey, also, if you're out there, let me know if you're interested in seeing LeetCode type stuff, or you'd rather see like project work or just kind of exotic stuff. Been thinking about streaming some stuff about literally streaming, like things like Kafka or Beam, Parquet files, data flow. All right, so what we're gonna do here is we're gonna give up. We're gonna give up on doing fancy things. See, numbers equals. I hate this because I know that there's a better way to do this. Does it tell me every number in here is twice? Yes. So it's not multiple times, it's twice. Okay. Now basically I want to transpose. So what's the easiest way to do that? We can make this a little more slick. Reduce this. So we're going to reduce our numbers. We're going to pass in a hash table. And then as we see numbers, we will return. Maybe this isn't any more slick. Return our hash. If I did that correctly, then we should have a hash table here with the keys and the counts. And then I can basically iterate through that. It will be roughly half the size. Half the size plus 1. What is it? Object.keys. And that would be my B. If seen numbers at B equals 1, and that's our number. There we go. Uh-oh, this should never happen. Okay. What do you think the chances are we got it right? It's taking a long time. Timeout. Scene numbers is not defined. Did I miss a parenthesis? All right, to the console. Oh, derp. Okay. So let's go ahead and look at what this returns. Okay, and if I do 2, 2, 1, 2, 2, 3, I get 2, 2, and 3 of 1. There we go. Or 1 of 3. And then if I say that whole shebang, but object.keys, I should get 2 and 3. Okay. For H is fine. So I'm saying for each key, maybe I shouldn't name it value there, it's kind of confusing. If the value equals 1, then return V. Oh, this is in a closure. Ah, geez. So yeah, herpaderp again. All right. So in this case, what I really want is a find. Return false. All right. So now if I do this, let's go ahead and make sure. What did I do wrong here? New hash. Ugh. Okay, so what I want to do is find v where exit v equals 1. V equals 2. Okay, so I mean, that looks good. Object.keys. Scene numbers, check, check. Find, check. Scene numbers at v, excuse me, equals 1, return. Oh, duh. Jeez. All right, that's nicer looking. I don't need this anymore. I mean, that all looks good. Let's try this again. Why is that taking so long? Okay, so got the answer I expected there. What if I take one of these things? here I'm looking for the answer 4. Alright, so that's good. So it's now 8:28 in the morning. I think we're going to go ahead and hit this. Okay. Interesting. Let's get some more details on the submission. So I'm smack dab in the middle here of runtimes. Look at the runtime. So interesting to see people were able to get so much faster. Memory distribution, where am I? So it looks like there's kind of two common approaches here. So I kind of wanted to see other people's solutions, but I'm not seeing how to do that. That's okay. As far as how to optimize this. Oh my gosh. Oh my gosh. Okay. I think I know how to do this a better way. Okay. So we've got the solution. Let's go ahead and save it just in case. But man, okay. So another way to do this that involves no extra memory would be to just sort the numbers. I should know that's always the solution, is to basically sort A, B. This reminds me, this is why JavaScript is not good for this. Alright, if A is greater than B, then 1, Y is negative 1. Okay, this does modify the underlying array, so that's a shame. But it's good because it doesn't allocate any extra memory. Alright, so now we've got a sorted array, and what that means is that we can look at every 2. So we can say for let I equals 0 less than nums.length I plus plus. Alright, what we can do is basically nums at I. Let's see. We don't want to overflow here. And we'll say I plus equals 2. So we'll do 2 hops here. So if nums at I is not equal to nums at I plus 1. Okay? So in this case, we're looking at the numbers, say, 2, actually it would be 1, 2, 2. Then I'm going to be looking at these two numbers. I'm going to say, oh crap, one of these is my bad boy. Now the next question, of course, is how to figure out which one is the bad boy. And the only way to do that is to look at the third number. Is that right? I can't look backwards. That doesn't really make sense. Say, okay, one of these is wrong, is single. All right. So now we've allocated, we've allocated some stuff for the sort in the background, surely, and we do have an integer. I don't know how you would do it completely in place without some sort of something there. So I don't know how you could do it without allocating any memory. I would love to hear your ideas if you have that. Otherwise, what we can do is say if I is less than, or say if you're greater than nums, if you're equal to, basically I'm trying to watch out for the last case here. If you're equal to, what am I trying to say here? No, we'll come back to this. if nums at I plus 1 is equal to nums at I plus 2, then we know that nums at I is the problem. Okay, otherwise, nums at I plus 1 is the problem. Okay, we do need to worry about this condition right here, though, because that's possible to have an overflow in the case that we've got something like this. Okay, so in this case, it's the last one on the list. What we'll do is we'll look at these two. This is fine. Oh, okay. That's no problem. So, okay, so we're okay with this. What we can do basically right here is if I, if we just run through every item in the list, then we know we can just return the last number, which is nums at nums.length minus 1. Okay, feel pretty good about that. So the two test cases that I want to see here, oh, weird, the editor is back to the one I'm used to. Huh. Where are my test cases? What the heck? Okay, well, I don't see how to do my test case. There it is. All right, so that looked good there. So 221, let's see what 223 looks like. This will be the case where it's the last one. Oh, excuse me. Hopefully I muted that in time. All right, so got the right answers there. So that worked out well. So let's just go with this answer. Do a little bit of cleanup here. Okay. Let's go ahead and submit the problem. I want to see a much better runtime, much better memory. Check that out. So it actually took longer and used a similar amount of memory. So that's funny. It did not end up being any faster. Okay, well, it's time for me to go to work, so I'm not going to spend any longer on this, but let's go ahead and look at, what's this notification? Let's go ahead, XOR. Let's look at C#. What? Aggregate by a to the b power. What? I don't know what that means. Let's see, numbers reduced. Yeah, wow, what the heck? So what does it mean to say a... I mean, that is what this means, right? If I raise a to the b power, let's see what that looks like. So if I've got a 2, call it 2, 1, 2, and I'm going to reduce, starting at 0. So I'm going to say 2 up to the first power. Okay. It's going to give me a 2. Am I not understanding how this works? Oh, I don't know what this operator means. Is this a bitwise operator? Oh, it's not. No? No. Let's see. Exclusive OR. Oh. Wow. Okay, and I even saw that in some of the answers, so that makes sense. So now if I say like 2 exclusive OR with 2 is going to be 0. So 1 is going to be 3. So it's going to like add those numbers together. Wow, that's slick. So if you can imagine if we had the 2, 1, 2 solution, 2, 1, 2, and those 2's are going to cancel out, and I should be left with 1. Wow. Yeah, and that's a solution that doesn't involve any memory allocation. So that is super slick. And yeah, I learned something there. So I'm going to count that as a win for today. All right. It's now time for me to go to work. So sayonara.